So in the previous example, we were looking at dilute. Okay, and when it is dilute, we are interested in the position in the electrochemical series. Okay, what happens when the concentration of the ions increase? Meaning to say now I have concentrated sodium chloride. Okay, so using the same example, or rather we should always draw this out to help us see better. This is negative, this whole thing is negative. What gets attracted to the negative is your cathode, cations, reduction is gain, and red cat. Yeah, so reduction, the cations get attracted over here. Okay, so same thing, concentrated aqueous sodium chloride, I still have my H plus and A plus. Okay, for metals, it doesn't matter whether it's concentrated or not. For cations, it does not matter if it's concentrated or not. Especially for your group 1 metal, it is very reactive. So it will always remain as ions if possible. Only when it's ions, it's 288 is stable. Okay, so same thing here, we will circle the H plus. Okay, but for your anions over here, this is positive plate. Positive plate, my anions get attracted. This is the anode. Okay, and then oxidation takes place, and then oxidation is loose. Okay, so what are the anions that are inside? I still have my Cl minus and my OH minus. Okay, but now that it's concentrated, okay, it tends to get promoted. The anion tends to get promoted. Okay, so instead of circling the OH minus, we should circle the Cl minus. Why I circle the Cl minus? It is promoted. Okay, so what are the equations that's happening? So let's write on the ions here. Your anode, we have my Cl minus, OH minus. Because it's concentrated, I circle the Cl minus. I have H plus and A plus. I will circle the H plus. Okay, so chloride ions are preferentially discharged over hydroxide ions as they are higher in concentration and easier to get oxidized. Okay, and on the cathode side, we will have your hydrogen ions are preferentially discharged over sodium ions as they are lower in the electrochemical series and are easier to be reduced. Okay, your half equations to write. So I have again my Cl minus naturally from Cl2. Write in the state symbol. Balance out your chloride. This is negative, this is neutral. I have to add the negative here. Okay, and over here at your cathode is the H plus electrons give you H2 gas. Okay, balance out your hydrogen atoms and electrons. So now your electrons is balanced, yeah? Okay, so your products, this is chlorine gas, observation, effervescence of yellow green gas. Okay, and your products on this side is hydrogen gas, effervescence, of colorless, odorless gas. If you want to write pungent, you will not be fault for it. Okay, overall reaction means balance out your half equation. So it's just H plus and Cl minus. Now I am breaking HCl aqueous. Okay, give you Cl2 gas plus H2 gas. Your electrons on both sides will even out. Okay, so what is the effect of your electrolyte? So let's look at it now. This is being discharged, this is being discharged. What's left behind? Your NaOH. So we can say electrolyte becomes more alkaline. pH increases. It was a salt solution, concentrated, pH is 7. Then it becomes sodium hydroxide, pH 14. Okay, and then note these equal volumes, right? When you write your balance equation, is 1:1. Equal volumes is when I have concentrated NaCl. Just now, the first example in the previous video, you have diluted NaCl, you get a 1:2 ratio.